Hello, good afternoon. So this is the new topic for chapter 5. So this is entitled Traverse and Traversing. So this is a new topic, but we are going to employ our knowledge on distance measurement and angle measurement. So we are going to combine distance and the angle, your bearing, and the azimuth in traverse and traversing. So before that, I'm going to give you the learning outcome and then the topic outline for this chapter. So we have here the topic objective. So at the end of this lecture, you should be able to define traverse in the traverse station and the other definition of terms. We have here enumerate the purpose of traverse. So why do we need to have the traverse and what are the significance of the traverse of our work as a data engineer? And then enumerate and differentiate the general classes and types of traverse. And then the last thing is identify the formulas for traverse adjustment and apply them correctly. So I am going to show you some of the sample problem in which we are going to employ traverse in traversing and do some adjustment of our traverse. So the topic outline that we have here is the definition, the purpose, the general classes, and the type. So I'm going to show you this one, and then the traverse computation, so the latitude and departure. So how are we going to determine the latitude and departure of a line given our bearing or azimuth and distance of a line? Then how are we going to compute the relative error of closure of our traverse? And then some adjustments. So there are two major adjustments that we can apply, though this is not that accurate, but it will be employed for estimation and then rapid adjustment of our traverse. So we have the compass rule and then our transit rule. So let's just have some recap before we proceed with our new topic. So you have here illustrate the following. So they have the bearing of the line AB, which is equal to 20 degrees east and 100 meters yung distance ng A to B. So we are going to draw this line AB, and then may another line pa which is BC. So therefore, connected yung tatlong points, yung AB and then BC. Then yung bearing naman from B to C is south 70 degrees, and then yung distance ng B to C is 200 meters. Now, if you are going to draw this one, okay, so let's start muna with AB. So if this is AB, yung bearing niya is 20 degrees northeast. So northeast dun sa first quadrant. So let's draw. So let's say this is point A, yung ating unang point or reference ng point is point A. And then we are going to draw. So let's say this is, we just draw here northeast 20 degree. And then we draw a line which measures 100 meters from A. So from here, we draw a line which is 100 meters. So let's say for example, that is equivalent to 100 meters. Then we can tell that this line here where the line stops, this is equivalent to 100 meters from point E. This is where the location of our second point, which is point B. So this is our point B. Now again, let's go back that the bearing of our A to B is equal to 20 degrees northeast. So this is equivalent to 20 degrees northeast. If this is 20 degrees northeast, therefore, if there is no error upon the observation, therefore, this angle here is also equivalent to 20 degrees east, west. But yung direction niya is southwest 20 degrees. So if this is 20, therefore, this remaining angle here is 90 degrees minus 20. So basically, this is equivalent to 70 degrees. Okay. Next line is BC, which is equivalent to south 70 degrees east and 200 meters yung distance. So let's start here from point B. So where is south 70 degrees east? So this is somewhere on this quadrant. So from here, since we're going to start to measure here, so let's draw a 70 degrees east. So from here, we are going to draw a line tikadto. So we are going to draw a line 70 degrees east. Then, yung length mismo ng line is 200 meters. So somewhere here, and then 200 meters along the way. So let's draw. So let's say, for example, that is equivalent to 70 degrees. So since yung direction niya is southeast, so third, fourth quadrant, 70 degrees east, and then you draw a line that is equivalent to 200 meters. So this one is our 200 meters. Then, if the 200 meters stops, then this is the point where we can locate our position of point C. Okay? So, this is A, B, and C. So, basically, if we are going to create the traverse, parang ganito lang. We measure the bearing. You have the bearing of the line or azimuth, and then you have the distance. And then you are going to connect those lines with stations. Okay? So let's have the definition of what is a traverse. So one method, a traverse is one of the methods in establishing horizontal control. So when we say horizontal control, so these are stations with known coordinates. So ito yung ating maging reference pag nagkakandak tayo ng survey. So how are the station or control are being established? So this is being established using the traverse. Ito yung method, the traverse method. Another definition ng traverse. So this is consist of series of straight lines connecting successive points whose lengths and direction have been determined from field observation. So, don't forget that yung pinakita kong illustration kanina, di ba? Series of straight line yan like AB and BC, connecting successive points, yung point A, point B, and then point C, where yung ating length, yung 100 meters and 200 meters, yun yung length ng each line, and then direction. So when you say yung direction, yung mismo, it could be the bearing of the line, or it could be also the azimuth of the line. So yung ating bearing and distance is observed on the field observation. So this is the common practice when we are going to conduct survey, if we are going to use the total station or the theodolite. So one of the data that we can get or we can observe is we can determine the direction of the line and then the length of the line. So another definition of a traverse, this is a point defining the end of traverse lines are called traverse stations and traverse points. So I have here another illustration of what are these traverse stations and traverse points. So this is the process of determining or measuring the length and the direction of the lines of a traverse for the purpose of locating the position of points. So one of the use of the traversing is if we start from a position of known position and then sobrang harayo pa aton i-observe na go-observe na lalat, then we are going to run a traverse. So the purpose is measuring the length and the direction of the line of a traverse for the purpose of locating the position of points. So we have another terms here. We have the traverse station. So these are successive points, temporarily or permanent of a reference over which the instrument is set up. So kung saan tayo nasi-set up ng instrument, yun yung ating tinatawag na traverse station. Okay, another we have also here. So traverse line. So these are lines connecting successive stations. So from one station to another, that line connecting to that stations are called the traverse line, or this is also known as the courses. So we have our different types of traverse. So we have the closed, the open, and the linked traverse. So for the closed traverse, it has two classifications. We have the closed loop and the connecting traverse. So when we say closed loop traverse, this is traverse that closes and returns to the first station. So let's say for example, it would create a shape of a regular polygon. So parang rectangle, triangle, quadrilateral. As long as kung saan ka nag-start ng point, doon ka din nag-i-end. Okay, so I have here have some illustration of a closed loop traverse. So let's say for example, this is traverse station 1, and then you observe this traverse station 2, and this is traverse station 3, traverse station 4, traverse station 5, traverse station 6, and you go back to traverse station 1. So this is a closed loop traverse. So kung saan ka nag-start, doon ka rin mag-i-end. So another type of a closed traverse is the traverse begin at the station of known location and closes on and ends another station of known location. So let's say for example, you have meron tayong monument. So let's have here, we have a monument. So yung coordinates niya, yung x and y coordinates nito ay 500 and 500. And then meron kang isa ditong, sorry. And then you have another point here. And then meron kang x and y. Let's say the coordinates of this point here is equal to 1,500. Okay, and then another is 1,500. So if we are going to run a traverse, since this is known dito, so this is our first station, and this also known. So mag-start siya sa known. So let's start here. So this is our station 1. This one our station 2. This one is our station 3. This one is station 4. And this one is station 5, or doon mismo sa known. So as long as it starts with a known and end with another known, so magiging close na rin yung kanyang traverse. Maski hindi siya bumalik doon sa start. Anyway, but these two, if we're going to connect these two, we can create another line since known naman yung ating first point here and yung ating point dito. So as long as it ends with a known point, then that is considered as a closed traverse. Okay? So this is an example of a closed traverse. This is a closed loop. So again, this is a loop. So this is a loop since, let's say, yung ating nagsiset up tayo ng instrument dito. So let's say this is A, and then measure the distance and the angle, or either the interior angle. So in this illustration, he measured the interior angle, then set up another station here at station B, set up another station, then observe this line, then observe this line, set up another station here, observe this line again, then observe this line, set up another station here, then do the back side, and then observe that line. So where it's started, that is the location also where you ended. So this corner here is our traverse station. So this is our traverse station, A, B, C, D, E. And this line here, and this line is our traverse line, or yung ating traverse force. So this here is our traverse line. Okay? So this is another type of traverse. So this traverse does not close. So it cannot be checked for mistake or excessive error. So one of the advantages of a closed traverse is ma-check mo talaga kung may error yung ginawa mong survey. So let's say for example, on our illustration, if you start at A, so if you start at A, then run to B, then you go to B, C, D, NE, and then you observe again A. So if there is the discrepancy in values, pag ni-read mo sa to A, therefore, there is something wrong with the observation before that station. So you can check. Pag close mo, hindi siya nagko-close, hindi naging 0, 0, or may malaking error yung closure mo, then there is something wrong with your data or your observation. Then one thing is you need to reconduct the survey, or you need to check for the error if pwede ba siyang i-adjust, or hindi na siya pwedeng i-adjust because too large na yung error. So there is something wrong with your observation. Okay? So when we say open traverse again, it does not close, so it cannot be checked for mistake or excessive error. So if you're conducting like isolated survey, subdivision survey, relocation survey, the open traverse is not advisable. Okay, so be reminded that once we submit our survey returns or our surveys to the DNR, they are going to check the error of your traverse. So if the error upon the traverse does not conform with the standard error, then your work will not be accepted. Then ibabalik ka in trabaho. So you need to do the traverse again. Okay, so this traverse does not close again. So let's say, for example, we start with A, B, C, D, and E. And then this E here does not have the known position. So wala siyang position, wala siyang coordinates. So nagpo-float lang siya. So we cannot check the error of this type of traverse. So why do we have to run a traverse? So number one is for the property survey to locate or establish the boundary. So I am going to show you some of the scenario in which the traverse can be used. We have here supplementary horizontal control for topographic mapping surveys. We have location and construction layout for highways, railways, and other public and private works. We have ground control for photogrammetric surveys, and so on. So before we proceed with the methods of running a traverse, then I am going to show you some of the actual scenario, what really happens on the field, and how this traverse is being used. Okay, so let's have here.